Alright, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD1100 or C# language programming language class, I've been doing a series of video presentations based on the textbook for the class, that being Murox C# 2015. Alright, so what I've been doing is I'm now in the database section, so I'm in Chapter 17. I've done 2 lectures. And hopefully this will be my last one on Chapter 17, so we can move on. Now I showed you a join and went over the components. Here is an insert. So I want to insert into the products table a product code of CS15, a description of Murox C# 2015, a unit price of $56.50, and an on-hand quantity of 300. So it's insert into the table. Then typically you put in a set of parentheses all of the field names, the word values, then another set of parentheses, the actual raw data that you're putting in. All right? Insert will not work if I already have a record in my products table with a product code of CS15. Here is an update. Update followed by the table name, set followed by one or more field names equal to something, and virtually 100% of the time in both an update statement and, as we'll see in a minute, a delete statement, you put a where clause in. If we left this where clause here out, so imagine this just said update products, set unit price equal to 54. That would set the unit price for every product we have in there to $54. Probably not what you want. This will only set the product code of MCCP to $54. Almost always what you want. And again, same thing with delete. Delete from followed by the table name. And again, virtually 100% of the time, a where statement. If we left this where statement off, it would remove every customer from this table. Now it's only going to remove customer 558 if they exist. All right, so in order to be able to grab this database information, which is kind of in one language, and use it with C#, which is another language, .NET provides, as it says, what are called data providers. And the core ones are shown right here. You've got a connection object. That will allow your program to connect to the database. You've got a command object, and that will allow you to write commands similar to these, and these, this, and this. A data reader. A data reader is called a fire hose, or known as a fire hose. If all I want to do is show every record in a table, I can use a data reader. It's read-only, meaning I can't change the data. It's forward only. So if I'm up to record 17, I can't go back and do anything, look at or whatever with records 1 to 16. Finally, there's a data adapter. All right, and what is an adapter? All right, years ago, my wife and I traveled to South America. We were told to buy an adapter for our electrical appliances because the way the electricity, the current, etc. was set up in South America wasn't what we were used to. So an adapter, very similar here, provides a link between the command object and the connection object and a data set object. All right? So basically, the .NET framework is really meant to work with SQL Server, but it'll work with any SQL type of database. It'll also work with what's called OLE. OLE is object linking and embedding. All right? And then there's also ODBC, Open Database Connectivity. Now, in here, some of the OLEDB and or ODBC stuff allows you to do things like work with a spreadsheet instead of a database. All right. These are the ones we're going to be most concerned with. SQL connection, SQL command, SQL data reader, SQL data adapter. When we want to use those, we have to add the using system.data.sql client to our programs. These are this is a diagram of the basic ADO, and ADO is ActiveX directory object. Don't worry about what it means because it's outdated anyway, but the name is stuck. All right. But you use data tables in conjunction with data adapters. Data adapters are used in conjunction with command objects. Command objects are used in conjunction with connection objects. Connection objects are used in conjunction with a database server. So, you come in here, notice we can go in both directions. You come here, you can go in both directions. Here you go in both directions. Here you go in both directions. So you might go here to here to here to here to here, back, 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 as an example. Now, this can result in problems, not for what we're doing, but if you've got two people who are using the same database, and they're each working with their own copy of the database. What happens if the first person finishes and goes and copies their copy back and makes a change to the master? Then 10 seconds later, the second person does the same thing. Probably the first person's changes are now lost. This whole thing is called concurrency. How do you handle it? You need typically to have some kind of concurrency control. So as it says, when two or more users retrieve data in the same row of a database table at the same time, it's called concurrency. And it says because ADO.NET uses a disconnected data architecture, meaning that when you ask for the database, you get a copy that you write back. The DBMS can't prevent this from happening. If two users try to update the same row at the same time, like I told you before, the second user's changes could overwrite the first user's. Whether or not that happens depends on the concurrency control that's used. By default, as mentioned in the bottom bullet, ADO.NET uses optimistic concurrency, meaning the program checks to see whether the database row that's going to be updated or deleted has been changed since it was retrieved. If it has, it doesn't allow the new change to take place. It throws a concurrency exception. It's kind of like the thing where you'd say, try again later. If you don't have this optimistic concurrency, then it's a game of what's called last in wins. That would mean if you had user A and user B, user A makes changes to table A, writes them back. 15 seconds later, user B, they both had their own copies, makes their changes, which could be totally different, writes them back. Now you've lost user A's changes. And as it says, it can lead to errors in the database. So how do you keep this from happening? Depending on the application, this may rarely occur. But if it's likely to occur, the program that uses the data set, you can design it so that it is frequently updating, which means that errors are less likely to occur. Another way to do this is to set it up so that when you ask to update a record, you only get that one record. So there's less of a chance that two users will be able to do things and screw each other up. So this is the basic dataset object hierarchy. We're going to be looking at this in chapters to come. This is the ADO.NET. We've already seen this. All right. ADO.NET objects created using the data sources window. We're not there yet. And here it is with code. I don't expect you to look at that code and have it make a lick of sense. That's totally fine. That's it for the chapter. Now, before I go on, and I'm not going to save here, before I go on to Chapter 18, our next chapter, which talks about how to work with data sources and data sets, I'm going to stop this lecture and then do another one. And the next one that I do, even though this is a short lecture, I'm going to give you some resources that you can go to find out more information. I'm going to give you some stuff that will help you start on your journey. All right? And I will be back to do that in just a couple minutes.